For our second example here, we've got the 0.5 inside the function. Okay? So one of the things that I often do with questions like this, here's the graph of g of x, sketch the graph of g of 0.5x. I see that 0.5x, and I think, what's that going to do? It's inside the function. It's going to affect my x values, and it's going to affect my x values by multiplying by the reciprocal. So you might think of 0.5 as equal to a half, and then the reciprocal of that is 2 over 1. And then we're going to state the domain and range of each function. So just like other days, what's going to happen, and you can, there's a spot right there that nobody's in, so you can have this one. Perfect. We can take individual points that we have. So again, on this one, looking now, the x scale is a little bit off. So labeling this point, I've got negative 3, 2. And if I multiply my x values by a 2, this will end up being at negative 6, 2. This point up here is at 1, 5. If I multiply that, negative 1, 5. If I multiply that x coordinate by 2, I'm going to get negative 2, 5. And so on a question where they give you the graph, you're going to just take the key points that they've given you. Here, our next one is at 3, 3. Multiply your x value by 2, and you get 6, 3. And finally, our last point here, at 4, negative 2, multiply your x value by 2, and you get 8, negative 2, connecting the dots. Whoa. Felt like that one was off a little bit. So that one just needs to move over. There we go, perfect. And then down. So what I did there too is probably easy to do. It's easy to label a point just a little bit off, okay? So you have to have also some things in place where you want to have checks. Do I have any others labeled off?
Negative 6, negative 2 is in there on negative 8.
Yeah, the negative 6, negative 2 is also on negative 8. There we go. Perfect. Okay. Now, exactly what I just did is super easy to do. Draw one point.
Gotta go out.
Perfect. I easily could label a point off. I really noticed it with this one on the right-hand side, because when I was going to connect the dots, I said, does my shape look like the shape has been stretched out horizontally? Or is the shape now different, like completely different? It's going to look somewhat different when you stretch something, right? But not completely different. So you can use that sort of as a check. Domain for our red function, it started at negative 3. And I'll use set notation this time. And the largest value for x was 4. And the range of our red function, its smallest value is negative 2. And its largest value is 5. Then looking at domain and range of our green function, the smallest value was negative 6. The largest value was 8. And the range stayed the same. Again, some things to reflect here. If all we did was multiply the x values by 2, does it make sense that your range didn't change? Because your range are your y values. And if we look at the domain from one to the other, can you see that it's just been doubled? The smallest value got doubled, the largest value got doubled, because that was the transformation that we were doing. Okay, questions for practice are for an 8. I have some forms and report cards to hand out to you, so I'll do that as well.